Okay, in this chapter we're going to talk about systems of equations. So I'm going to start off by talking about what exactly do we mean by a system of equations. And mainly it's going to be when we have two or more equations that go together. And in this section we're going to be looking at linear equations. So the graph of each one of these equations individually would be a straight line. And when we talk about a system of equations, we mean the two of them together. What points do they have in common, or what values of the variables x and y can we plug in to make both equations true at the same time? So this is actually something we've seen before. One way that we've talked about solving systems of equations before is setting two equations equal to each other. So we use this when we were finding like the equilibrium quantity and equilibrium price. If we had a supply formula and a demand formula and we wanted to know what's the equilibrium quantity and price, since both of these equations are p equals something, they have to have the same p. So that means p has to be 5q, and it also has to be 200 minus 3q. And so if we add 3q to both sides, we get 8q is equal to 200, and divide by 8, the equilibrium quantity is 25. And once I know the equilibrium quantity, I could find the equilibrium price by plugging q into any of the previous equations. I'll probably pick this top one. That looks pretty simple. P equals 5 times q, which means 5 times 25, and 5 times 25 is 125. And so there's our equilibrium quantity and price. But we could also think about this as being a solution of a system of equations. We have a pair of equations that came together, and we were able to come up with a solution to them. Okay. At the beginning I said that we're talking about linear equations, so the graphs of both of these are straight lines. So that's another way to think about how to solve it. Something we've seen before is graphing straight lines. And it turns out if you do graph straight lines, the solution of the system is going to be what points they have in common, meaning where do the two lines intersect. So that's our second method. Again, more or less something we've seen before. We can solve by graphing. So I'm going to look at an example. Solve y equals 4 minus x and y equals 2x plus 1. Okay, so staring at these two, we know their slopes and their y-intercepts. In this one, our slope, the number in front of x, is -1, and our intercept, the constant, is 4. This one has slope 2 and intercept 1. So just using that, I can come up with a graph. Alternatively, you could make a table for each one. That's totally okay. Okay, so let's see what we get. 1, 2, 3, 4, 5. Okay, so intercept 4 and slope -1 means rise over run is 1 over -1, or -1 over 1. So we go down 1 and over 1, and then down 1 and over 1, and down 1 and over 1, and down and over. Okay, so there's my line y equals 4 minus x. My other one has y-intercept 1 and slope 2, meaning rise 2 and run 1. So over 1 and up 2. So this one is actually going to go a little off my chart here. Over 1 and up 2. Everybody pretend I drew a straight line. Yep. Okay, so the second line is y equals 2x plus 1. And again, finding the solution of a system of linear equations means where do the lines hit? And so they look like they're hitting right here. And let's see, this is the point x is 1 and y is 3. So this is the point 1, 3. Or x is equal to 1, y is equal to 3. So this is a good thing to point out, is that there's multiple ways to write it, your answer. You can write it as a point, or you can write it as x is this, y is this. In the previous one, we didn't write it as a point, although we could have. We just have to figure out, do we want to write p comma q or q comma p? I'm not really familiar with that. It doesn't really matter to me. Okay, While we're still on the topic of graphing solutions, I want to talk about one other thing, which is the form of your answers. So if we're graphing two lines, either they're going to be two lines that hit, they're going to be two parallel lines, or they're going to be what are called coincident lines. And coincident lines means that they're actually the same line. So if my first line was this and my second line was this yellow one, then those are actually the same line. And then if I look at them left to right, how many solutions are we going to have? How many places are they going to intersect? These guys are intersecting at one place, so that means we're going to have a unique solution. Something to be aware of though, this was also a unique solution. We still had an X and a Y. That just means there's one point. There's not multiple points. This guy has no solutions. There's never a point that these two parallel lines are going to intersect. And this one, my black line and my yellow line are actually the same line, and so there's infinitely many different points I could pick that are on both lines, so infinitely many solutions. And it turns out if we're talking about linear equations, these are the only possibilities. Either we're going to get one answer, no answers, or infinitely many answers. You can't get two answers. Because if somebody told you that two lines are intersecting at two different places, then you're going to say, what the heck is up with that second line? Lines are not going to curve. You're not going to ever have this. Sad face. Okay. We're only going to ever have one solution, no solutions, or infinitely many, a whole ton of them.